So hello guys, I'm back with another video, and this time it's question number 10, ISI Bstat 2007 subjective paper. So the question is, A is a set of positive integers, natural numbers, satisfying the following properties. If m and n belong to A, then m plus n also belongs to A, number 1. Number 2, there is no prime that divides all elements of A. Okay. Now part A of the question is, suppose n1 and n2 are two integers belonging to A such that n2 minus n1 is greater than 1. Show that you can find two integers m1 and m2 in A such that 0 smaller than m2 minus m1 smaller than n2 minus m1. Hence show that there are two consecutive integers belonging to A. Let n0 and n0 plus 1 be two consecutive integers belonging to A, and show that if n is greater than or equals to n0 square, then n belongs to A. Okay, this is our question. We'll interpret this question, okay? We'll analyze the question, what it actually is. See, if m and n belong to A, then m plus n also belongs to A. Okay. So m and n, if now if we put m equals to n here, then you get 2m belongs to A, 3m belongs to A, 4m belongs to A. Okay. M square belongs to A, m cube belongs to A, 2m square, 3m cube, 4m power n belongs to A. Any number of the form A m power b belongs to A. Okay. This is the interpretation of the first question, that A where A and B are natural numbers, or you can say P and Q. P and Q are natural numbers. If P and Q are natural numbers, then P into M power Q belongs to A. This is the interpretation of the first statement. The second statement, if there is an integer A or a natural number m belonging to A, then there exists an integer m dash or a natural number n dash such that they are co-prime, okay, or no prime number divides both of them. Okay. Now what we have to prove? We have to prove that n1 and n2 are two integers belonging to A such that n2 minus n1 is greater than 1. So you have to find two integers m1 and m2 in A such that 0 is smaller than m2 minus m1 is smaller than n2 minus n1. Now how will we do this? See, the approach is going to be like this. N2 minus n1 is greater than 1. So the least value it can take, as n2 and n1 both are integers or positive integers, is n2 minus n1 will be 2. The least value n2 minus n1 can take is 2. And so from that, the least value m2 minus m1 can take is 1. So m2 minus m1 can take value is 1. Now if n2 minus n1 takes value 2, then m2 minus m1 will take values 1 and 2. n2 minus n1 is greater than or equals to 3. Then m2 minus m1 will take values 1 and 2. Okay. So it will go like this. Now okay, this is the interpretation of part A, how we'll approach the problem. The interpretation of part B is, show that there are two consecutive integers belonging to A. And now we'll show that from the part 1 only, we'll show that m2 minus from a sub part of part A is that m2 minus m1 will be equal to 1 for any m1 and for any m1 m2. Okay. Now any m1 m2 belonging to A. Okay. Now we are given n0 plus n0 plus 1 be two consecutive integers belonging to A. Show that if n greater than or equal to n0 square, then n belongs to A. Now we'll do something with this that I'll show you in the solution. This expression uh, can be broken into further made simpler. So we'll move on. We'll see the solution. Okay, the solution goes like this. Suppose we have a number a belongs to the set capital A. Okay, then according to the question, there always exists a number b belonging to the set capital A, such that GCD of A and B is 1. Then there now this GCD, the property of GCD is that there exists some integers x and y such that mod of ax minus by equals to 1. This is known as BEZOUT'S theorem, and this proves the second part of the question. Okay, how this proves the second part of the question? See, if GCD of AB equals 1, then we can write mod ax minus by equal to 1, where x and y are integers. Now A belongs to the set A, so AX also belongs to the set A. B belongs to the set A, so BY also belongs to the set A. Okay. So we get two consecutive integers. Okay. So we have proved part B of the question. Two consecutive integers we have got, so we have proved part B of the question. Okay. Now, for part A, we have the least value of n1 minus n2 equals to 2. Okay, and the least value of least value of m1 minus m2 equal to 1. Now we are given that n1 and n2 belong to A. Then we have to prove that m1 minus m2 both belong to A, their difference being 1. We've already done so from 1, where m1 was ax and m2 was by. Okay, we've already done this one. So now we'll prove this for n1 minus n2 equals to 3 equals to 4 equals to 5 and so on, because we have done this for n1 minus n2 equals to 2. Now we get m1 minus m2 equals to 1 comma 2, the set containing 1 and 2, for n1 minus n2 equal to 3. Similarly, m1 minus m2 contains the elements 1, 2, 3 for n1 minus n2 equals to 4 and so on. Okay, so we'll prove this. See, ax minus by equals 1. So we multiply this equation by 2. So 2ax minus 2by will be 2. We multiply this equation by 3. So 3ax minus 3by will be 3 and so on. This is now by property 1 of set A. This is by property 1 of set A. We'll use this property. Put 2ax equals to m1, 2by equals to m2. So we have proved mod m1 minus m2 equals to 2. Similarly, put 3ax equals to m1 and 3by equals to m2. Okay, then we get m1 minus m2 equals to 3 and so on. Note that if A belongs to the set A and B belongs to the set A, then ax plus by belongs to A by property 1 of A. Okay, I hope this is clear, because see, I'll explain you once more. Here we have multiplied this equation by 2 and put 2ax as m1 and 2by as m2, and we get m1 minus m2 equals to 2. Again, we can do this we can multiply this by 4, 5, 6 and all other natural numbers. So we'll get m1 minus m2 to be 2, 4, 1, 2, 3, 4, 5, 6, all numbers. Okay, up to any natural number. Okay, actually any natural number. Okay, now the third part. The third part, we put n greater than equals to n naught square. So n and n naught square are integers. So we assume k to be a positive integer, add it to n naught square and make it equal to n. This can be written as n naught square minus n naught k plus n naught k plus k. Adding and subtracting n naught k. Okay. Now take n naught common. N naught into n naught minus k plus k into 1 plus n naught. Now what is this? This is now 1 plus n naught and n naught belong to what? Belong to the set A. So n naught into n naught minus k will belong to the set A, n naught plus 1 into k will belong to the set A, and their sum will also belong to the set A. So n will belong to the set A. Hence you have to do the third part, and that's hence we have proved the question. So thank you.